record this stuff. Okay, and I think we can get going. So, welcome everybody. This is a sprint review for sprint 3, and that's the final sprint in Drake. Next week, we're just going to be running some bug fixing and final wrap-ups before the release. This last sprint was a 2-week sprint, and consequently, we tried to appropriately adjust the number of points that we took on. So we originally actually took on about 110 points, but then through the course of the sprint, there were additional points taken on because we had people that needed to finish certain things. And so we ended up with about 150 points, and we completed about 110 of those. So we actually completed pretty close to what we originally planned. It's just was different stories. So we're getting a little bit better, but I think there's still room for improvement in terms of appropriately scoping the work and then completing it at the end of the month, at the end of the sprint. So with that, just as a brief summary, let's launch into the individual areas. On a platform side, even though a lot of the GUI security and REST API security was done in the prior sprints, it was really not fully enabled, nor was it documented. And so this sprint, we documented it, and it's actually by default now enabled. And this allows HTTP, HTTPS, and form-based login and basic authentication for REST API. And for CLI, it uses key-based certificate. On a core side, I don't think if Madan, are you there? I think Madan's actually at another talk. So let me cover the core here. Number of the previous topology-related stores, such as link and device store, were not implemented using the EC map. And so this sprint, Madan went through and ported them to use EC map. In the process, eliminated a number of complexities and made overall code smaller and actually faster performing. Also, as part of this work, the consistent map was improved to be able to be viewed as just a plain map. This simplifies the programming model for applications that just need to be able to place items in a distributed map using ordinary abstraction. Also, underneath the hood, the retry on failure logic was fixed in a number of places and was simplified. This was to deal with conditions such as concurrent locks or concurrent timeouts. Previously, there was boilerplate code polluting applications to be able to deal with those conditions, which are unavoidable, so they have to be dealt with. But the improvement eliminates that boilerplate code and centralizes the code in a nice facility, central facility. And also some improvements were done on the leadership service to make it easier to use. And of course, there were a number of fixes, bug fixes dealing with either various types of exceptions like null pointer exceptions under certain corner cases and some timeout exceptions as well, where there were some race conditions. So roughly speaking, that's done. So that this shows that the functionality that was originally slated for Drake in this area is actually done. So that's great news. On a northbound, normally Brian would cover this, but he's also with Madan speaking at Hot Interconnect, so I'm going to cover this as well. There were a number of work happening here. First of all, the incubation of the intent domain subsystem, which is intended to serve as a basis for a rework of the intent subsystem in the future releases to make it more usable and extensible. That continues. Both the API and the rudimentary implementation is in place in the incubator, and a simple application is being developed to test some of the key concepts. The network configuration subsystem was moved out of the incubator, and all of the applications, I think all of them but one, Actually, sorry, I take that back. Two applications, SDNIP and segment routing, are still need to be converted to use the service. Presently, they use their own configuration mechanism. I think SDNIP, that's a work in progress, but it has not been finished yet. And finally, resource reservation. Sho, do you want to talk to that, or do you want? Sorry, I didn't mean to spring that on you. I just figured you can cover the resource stuff.
In this sprint, I focused on the supporting the hierarchical structure of the resource, and I completed the implementation of the hierarchical resource structure support. And the resource is needed to be registered before the allocation or deallocation. So I implemented the resource registration mechanism on when the resource such as device port, link are discovered or are removed. Thanks.
Thank you, Sho. So on the southbound side, and normally Ali would cover this, but he's in flight somewhere from Canada. So I'm going to cover this. The OVSDB plugin, which is work predominantly done by Huawei, is nearing completion. And same applies to the PCEP plugin. Is there, if anybody is on a call that from Huawei that would like to speak to this, please feel free to jump in. Okay, if not, then we can move on. Also, Loxy has finally, the changes that we made to Loxy. Yes?
Hello.
Yes?
Yeah, I am Mesh. I am Mesh from Huawei ONOS PCF team.
Great.
I am going to, we are going to give demo on PCF tunnel provider. So along with me, Panindra and Bharat are there, and Suresh, they are going to join. So
great. So will you do demo at the end?
Yes.
Okay, great. Now, is there a few things that you needed to say about these two pieces of work, the OVSDB and PCP plugin? Or do you think that this captures this?
No. In the next slides, we are going to explain.
Okay, great. Okay, so let me finish this slide and I'll hand it over, okay?
Okay.
So also the Loxy changes that we made were submitted to upstream. So now the official version is being built as an OSGI bundle, so we no longer need to rebundle it. But unfortunately, I think we may need to continue to publish this to Maven Central ourselves, because I don't think Big Switch is interested in doing that. Also, some of the changes that were pushed upstream include fix to the metering portions of Loxy. And related to that, our metering service implementation has been finished. At least enough of the functionality for the Drake to carry. Okay. So the PCEP tunnel provider work. I'll let you guys take that.
Umesh, I think his name.
Umesh, do you guys want to cover the PCEP tunnel work? I wonder if you lost them.
Maybe I forgot he will give a demo, so we need a demo. Before the demo, we can give some this one.
Okay, well, we can always return to this if they come back. Simon, are you online? Do you want to talk to the GUI?
Yeah, hi, sorry, just unmuting myself here.
No worries.
So the GUI work that's been done in this sprint is basically under the covers. There's been a major refactoring of the way the traffic visualization has been implemented. Essentially, we've decoupled the semantics from the presentation, and what I mean by that is we've now created a general highlighting toolkit that allows an application to use an API to instruct the topology view to highlight links and or nodes and show information. So the traffic visualization has been reworked to use that API toolkit. But I've also implemented a demo overlay application which shows that we can control particular aspects of that visualization. So anyway, probably better to show you later than to try and labor over a textual description.
Sounds great. Thanks, Simon. Just on a miscellaneous front, we've released the ONOS Maven plugin, which includes the ability to generate REST API documentation for the Swagger UI. The documentation is generated based on information in the Java docs and based on the JAX RS annotations. So also associated with that, all of the applications except one have been documented appropriately to be able to support nice REST API docs. Also, Charles Chan enhanced the OpenFlow controller to be able to make the port configurable. And we have a pending commit for changing the port number from the old 6633 to the official 6653. But we decided to wait with that until EMU, until we can properly communicate the change to everybody. We didn't want to change the port number and have people whose environments were not properly configured to be surprised. But it should be a fairly small change. Mostly the issue there is just getting the things communicated correctly. Also, some work has been done for be able to incorporate basic system integration tests as part of the Gerrit verification build. We've had a number of times throughout this release where the build passed verification, but then when we tried to ignite the product, things wouldn't load correctly. And this work is aimed at preventing this and catching it during the Gerrit verification build. So that we'll see, for example, if an incompatible change was made to the drivers or to some code that was missing some dependency from third-party libraries and things like that. Also, there was lots and lots of churn in Gerrit, so there was a lot of work reviewing the code, which is great, which seems like bad news. I don't mean it to sound like bad news. It's actually good news because that means that we have an increased number of contributions from other partners, and that's actually very, very good. So it was not meant to complain about that. It was just that's good news. Okay. I think now I can pass it to Harry or Subin.
Okay, I'll just go. Okay, so we started out the sprint with some of the leftover stories from the previous sprint, and this time we tried to keep it minimum number of points by looking at the last sprint because there were so many points untouched, not even in progress. So we tried to pick up very few stories and few tasks along with some new stories added. And as you look at it, like IPv6 test suite status is currently it's in Gerrit. I'm sure it's going to take another week for that to be completed and moved to production. Basic sanity. It's not a full-fledged sanity because we have some issues with generating traffic to match certain IPv6 fields. We are still investigating what tools to pick, and we don't have any one tool that does it all, especially the open source tools, since we don't have commercial traffic generators yet. That is one thing. I think that is going to be a difficult situation for those guys working on IPv6 because they may need the particular types of traffic patterns to verify all sorts of IPv6 entrants. We'll look into it during the EMU release. Hopefully, we'll have some solution for that. And the other thing is REST-based intent. We added basic REST coverage. It's not a full-fledged coverage, but it still verifies the intents, some of the basic intents. And that will also have the same issues where we want to create different types of intents. If I want to match them, we don't have the packet generation. But right now, so far, it does the REST intents, calls them, installs them, verifies them, but there is no data plane verification. And the next one is OVSDB level 1 and 2. They're all moved to production cluster so that they can run nightly. We did verify those and then move. So that the process is we verify them and then we move them to production cluster. So that means they went through the process cycle. If you see them, they are in production cluster. And you should be able to see them on the wiki, the results. Wow, guys. So IPv4 Funk Intent Test Suite, it went through some refactoring that was already in production, but we did some minor refactoring there, as well as HA Test Suites. I think John has been constantly refactoring every time he sees some issues, he's adding, updating all the time. And the Cho test, I added basic IPv6 support in the Cho test so that I can run longevity testing along with IPv6 just to see if there is anything breaks over a period of time if I'm running IPv6 continuously. That was the motivation. And another thing is we have new test suites added. One is the scale topology, and another one is scale intent test suite to verify up to the maximum number of intents. I think we're trying to go up to 1 million and to see if there is any impact to the memory and then CPU issues. Those two are in Gerrit and they're not ready yet. So they're mostly next sprint or before if you have some more time before emo, maybe they're going to production. And we got a first-hand look at the security mode cutoff. I think Shang Hoon was here sometime back, and Subin and Glenn, they worked with him on running the secure mode cutoff to just get a feel of it. They did. I think they still think that some more further improvement is needed on that part. That's pretty much about the sprint work. And we have some couple of regression issues, and those are already listed out in the next slide that I have, along with the Jira bugs to map to those. And that is the number of bugs that were added between the sprint. But if you look at the number, might look higher. Actually, the number is very low if you exclude the OVSDB bugs. Most of the 75% of the bugs were from OVSDB. So basically, ONOS bugs were very few. Actual ONOS core bugs were very few. And resolved were 15, and we still have 89. I think that is lesser than last sprint overall Jira bugs flow status. So if you go, and those are the bugs we are trying to get resolved either during the next week or during the next release. First sprint, hopefully. And some of them are like Cbench. I think it's under low priority right now, but we would like to see that is working if we want to show the performance numbers consistently. And there are some other bugs like missing flows and some of the performance issues. And there is one more issue, HA issue, and all areas there are one. I picked a couple of them from each area. That's all I have. Thank you.
Thanks. No.
I'll speak for Luca on the deployment, maybe without the Italian accent. So Luca spent some time in sitcom for a week or so, but he still managed to have a few things completed. One is that we set up a test bed internally together with in the Proxmox setup. So he was able to set up the Internet 2 test bed internally on the Proxmox infrastructure. That's ready to be used and do regular testing. And then he spent some time on Proxmox and finished all the migrations that's outside ONOS, but that helps out ONOS as far as setting up infrastructure for testing and some minor network issue that got resolved. The next slide will show that this is one of the deployment that's running today in Korea, the Korean Act. They are running 7 instances of ONOS in 2 locations, one in Seoul, one in Daejeon. And then they hooked up to a set of real switches, including optical switches in the Sienna, and the packet switches of Brocade and Arista, and then with some OVS switches on the edge. The next slide will show you the GUI. Well, next slide is showing the actual equipment. So it's nice. We should have everyone posting on the demo slide in the future. So those are actual equipment, and next slide show you the GUI, showing that's live. And the plan is that they're gonna run SDN the IP application first, and when VTN is ready, they're gonna start trying out some VTN virtual tenant network application from there. So that's the deployment.
Cool.
Brocade and Arista running OpenFlow?
Yes, I believe so. I mean, that's what's being discovered.
Okay.
This is broken for one part of it.
OpenFlow.
So, who are these people?
The Koreans, actually, I don't know if it's Korean net. It's the research network in Korea, right? Research and academic network. So next sprint we will have, they planning to run SDN IP. That's the first application they're trying to run. And at the moment, I don't have any update on that. So the next sprint probably will have much more data on the actual application running on top of those.
I don't know how to get that.
To get that. I've not seen it before.
Oh, you haven't seen that before?
So this is a cool network. Have you guys tried some of the failover capabilities, HA, on this network?
On this network, I don't believe so. They just have it install ONOS and just started trying to run an application. I don't think there's a whole lot of work being done on top of it yet. But
Thank you.
like I said, next sprint, I think Luca will have more detailed update on what they're running. Okay.
Sounds good. Thank you. All right. On packet optical, Mark, I don't think you're online, are you? I don't think so. He's in Europe, so that would be really, really awkward time for him to be online. Ayaka, do you want to speak to that, or do you know? Very involved in this.
I was just kind of busy doing that presentation.
Okay, no worries. All right, so there were just, for the most part, the packet optical work is just continuing slow burn. There's some changes to LOXI to add support for optical transport, and then a few fixes to the test infrastructure, to the optical emulator. That's all we have. I'm sure Mark would be able to add more detail if he were here. Okay, for ONOS framework, I'm going to let someone else talk. Will that be you, Honta?
Yeah.
Great.
This project is for OpenNFV. We try to provide the ONOS framework for OpenNFV. We have identified multiple couple of modules that need to implement in ONOS. So in this release, we implement a couple of modules. This include the OSDB driver, and also we implement a controller and OSDB protocol 747. And also we create an application. We also implemented a virtual network management. This is our current solution for the OpenNFV. And also we create a VTM manager as an application. So this manager can create the virtual network and the virtual VTN, the virtual tenant. And in this ONOS infrastructure, the user can create the bridge, the port, and the VIX line on the VM. So we will give a demo after Thomas finishes this slide. We will give a demo. The demo will show how we create the network, the tenant. Okay.
Okay.
Yeah.
Sounds good. Thank you.
The OSDB driver and provider, they were different. In your previous slide, you mentioned there are two components. Right?
Yeah, can you go back to the previous slide? Yeah, thanks. Yeah, are you using ONOS terminology over here? I can see protocol provider maybe, but there's a comma between that also. And
yeah. We also implement OSDB the provider. The provider just is for the OSDB event information report to ONOS.
okay.
So
what are the other two?
OVSDB is used, if I may, OVSDB is kind of used in two different contexts. There's an engine that underlies the two different usages. The engine underlies the use of the provider, through which we can report the hypervisors which are running the OVSDB server on it, and that's done through provider mechanism, and then also through it's used to host the various drivers, because the drivers are used as a mechanism to be able to create bridges, configure the ports, and stuff like that. So the configuration type activities are handled through the driver mechanism, and the provider mechanism is used to just inject the devices. The device here being the OVS server, essentially.
Both sits in the southbound of the ONOS.
Yeah, both sit at the southbound. Yes, exactly, and both use the same OVSDB engine and the implementation of the protocol, the library.
OVSDB.
Yeah.
Sorry, go.
I was going to ask for the controller.
Yeah.
What is the OSDB controller?
OSDB controller is when we implemented the OSD protocol, we provided this controller.
It's analogous to our OpenFlow controller, the component that sits
Yeah,
there
it's
that
like
manages the OpenFlow connections. The OVSDB is the stuff that actually act as a client to the OVSDB server.
Yeah, this looks like the OpenFlow controller.
Does that answer your question? Okay, great. Okay. So on a cord side, do you want to cover that?
Yeah.
Great. Here, do you want to step up to the mic?
So normally Ali will be talking about this, but since I know what he's been up to, we've been looking. He's been trying some things regarding OVS's support for how should I put it? He's been looking at the hashing capabilities of OVS when creating VXLAN tunnels. Specifically, do VXLAN tunnels include information about what is being encapsulated? And he found that in fact it does, because it hashes the inner flow and puts it into the UDP source port, which is part of the VXLAN encapsulation. And that's important because once you put that information in the UDP source port, when that hits a fabric switch, which is a hardware switch which does its own hashing, then it's essentially hashing on the inner encapsulated flow information as opposed to something outside. There's metering support that's required in the optical line terminal that'll be part of the cord. So metering support was added to ONOS, also by Ali, and now he's testing it with the OLT, and there's a bunch of issues. Then sort of cord in itself is big enough and involves multiple companies and multiple organizations. So it was decided that cord itself is going to become a different Scrum board, different project board on Jira. So if you go to Jira now, you will find a board for ONOS and another one for cord. And in that cord, you'll find there's multiple different epics, and Scrum groups are being created for those epics. And of course, there are similarities with the work that Huawei is doing with ONOS and OVSDB. So Ali is also looking at Huawei's implementation of OVSDB that we hope to leverage for cord as well.
So which part do you try to use? Just in the southbound?
Southbound, yes. Yep.
Even the VTN functionality.
The VTN functionality, well, not so sure. I guess I don't know enough of the VTN, so I'm actually looking forward to the demo.
Yes, starting at the OVSDB for sure. Okay, thank you. Thanks, Saurabh.
The next slide is also mine.
Okay, that's right.
Right, so as part of CORD, we're creating a leaf spine fabric. We demoed it at ONS a couple of months back. It's the same fabric, but we've changed the hardware that we're using in that fabric. We are now going to use sort of white box switches with open source software on it. That open source software stack uses Open Network Linux, Indigo OpenFlow Agent, and Broadcom's OFDPA abstractions. So there's a lot of work just to make sure that hardware is doing what it's supposed to do. We have found bugs. Flavio did a lot of work, found bugs. We reported it to Broadcom. Broadcom is sending us fixes. So if you look at the Jira Jira board for the CORD project, you will find there are a lot of stories now that are just about testing this hardware and the software that goes on it. In the meantime, the overall design for CORD is also coming together. The fabric is one piece of it, the central piece of it, but on top of that, we'll be doing overlay virtualization using VXLAN tunnels. But then we'll be doing a lot of these XOS style service composition that involves scaling, creating virtual networks for services and scaling those services at runtime, adding VMs, removing VMs and also doing load balancing between those between the VMs that make up a service virtual network. So there's discussions and a discussion document that is being created for this overall design. It also, of course, includes residential access, which is what the OLT stuff is about. It'll also eventually include WAN access, which we haven't really talked about a lot. But so this design is coming together. The sprint is the first CORD sprint will start next Monday. So yeah, if you're interested, take a look at the CORD board.
Great, thank you very much, sir. Right, yeah. I'll here. Let me pass the mic to Shrikant.
Okay, on the ACORD front, this is analytics for CORD. Our investigations on the Ceilometer framework is continuing. So in this sprint, we focused on two parts of Ceilometer framework. One is the notification framework. We wanted to understand how the notification listener and how the publishes to this listeners. So we tried to write some sample listeners inside the Ceilometer and developed few sample Python-based publishers, which publishes the messages and see whether they are getting received by the listeners. So that is successfully done, and we're planning to use the same logic in all of our CORD related instances. So the CPE, OLT, BNG, in fact in future ONOS also can use that publishing logic to publish any notifications towards the Ceilometer framework. So that is one part of the investigations. The second part is we wanted to run the back end of the Ceilometer as a scalable service. Today, when you deploy Ceilometer, both the database and Ceilometer runs in the head node, which we wanted to decouple and run the database on a separate slice so that it can scale it on its own and Ceilometer can make use of it for future scalable purpose. So we tried to use the MongoDB in these experiments and installed in a separate slice and configured the Ceilometer to use that, and that is also successful. So these are the two experiments we have attempted in this sprint and done with it. That's it.
Perfect, thank you. I don't think we have anything from Icona. I think work has happened, we just simply haven't gotten any report of it yet, so I'm just going to skip over this. On the built-in application side, Sam, do you want to speak to that? Or?
Last sprint I added. Yeah, you can
I added REST APIs for the DHCP server. I added some 5 of them, and I'm currently working on the server GUI. Trying to add that next 2 weeks.
Great, thanks. Also, as a spare time project, there was a cluster IP alias application, which is a small application which manages a sort of a shared IP alias that's passed between the various ONOS nodes depending on their availability, and gives a single point of contact to for REST API or CLI or GUI. Now, this is just a small application, very low end. It's not intended to replace something like HA proxy or Nginx. Those are clearly much more robust load balancers. This is simply something that you can just install, give it an IP address, and it will keep going. I can give a demo of this at the end.
Does it use any VRRP kind of protocol to detect whether node is down?
No, it just currently uses its own. ONOS currently has its own mechanism for detect node failures.
And whenever node failure is detected, it does.
Yeah, it basically just there's a ongoing leadership election, and if a node loses an election, somebody else picks up the leadership and instantiate the address, and the other node gives it up. Okay, and so it's very straightforward. Yeah.
This means this is a virtual IP kind of stuff.
Just think of it as a virtual IP for the cluster. Yes, it's not intended to do any load balancing whatsoever. This is simply just having a single point of contact. So if something happens to one node, you don't have to become aware and try other nodes manually. You just can talk to the cluster using that IP address, and you'll be given to one of the instances, and you really don't care which one. And it's using IP config and RPing. It's very straightforward. All right, I'm going to let Ping Ping talk about SD and IP performance.
This sprint, I tested the SMP with multiple three ONOS instances and also about 100 peer and 600,000 routes and 6 OS switches. We used the multiple OS switch D and OS DB server. That helps a lot. But in the overall, currently we need to install the routes very slow. The interval is 20 ms. Then otherwise, the OBS will be busy and things will go wrong. This is not very good. This number because you need for the setup, you need few hours. You need few hours to set up the whole system. The bottleneck is located at the communication between OBS and ONOS. If we use the same environment, also run ONOS cluster, but only connect all switch to single ONOS instance, then everything is fine. But once you connect to all the three, then things will not good because of communication. So in next step, I need to add a new feature during the failover. I need to add the speed control to the internet synchronizer, not to install the flow interface too fast. When one instance dead, change to another. This is a new feature need to be added into the SDIP. And some possible optimization between the OVS and ONOS communication, like this is just an optimization, like the states collection speed. And for some of the states in SNIP, we don't need it. Maybe we can disable it, just totally disable it. And the flow remove notification is a serious problem. If you just remove a fail interest and notify, that's fine. But usually when there's the network is something going wrong, and there will be a lot of flow notification remove to the ONOS, it will totally block the communication. Like the ONOS lost links. This is a very typical, yes, very typical. I can always see this happen. And another thing is maybe optimize is the packet in. The serial is the packet in maybe can only report to the master ONOS, but right now we report to the standby. Then maybe if we don't report to standby, then maybe you can reduce some traffic. This is what I have found so far.
Okay.
So between last sprint and this sprint is that last sprint was one instance and this time is 3.
At the very beginning, I think set up the 3 is very easy. Just set up the whole environment, but it not work. When I set up the 3, it only handles 3,000 and 4,000, and then it's totally bad. So we need to find the one by one, and then you need to in the code to comment some code and see what the effect looks like. And this.
Okay, I'll talk to you.
Okay.
We think we should need to isolate whether it's an OBS problem or because this doesn't match up with what we see with the node provider when we test performance. Right? It's either SDNIT side of the things or the ONOS core or it's OBS. It's not clear enough.
Clearly, it needs to be flushed out exactly where the problem is.
Right.
Because I don't think it's because of OBS.
No, but that there is a discrepancy. Right? Our current test of flow.
Yeah, but your null providers aren't OBS. They're not
Right,
real open
I know,
flow switches.
exactly. That's how we should isolate where the problem comes from.
So you think it's not because of OS?
No, I don't.
They can copy it.
Either the provider,
okay.
either southbound.
Yeah.
That we don't include the node provider.
Yeah, except this, I also set up the test case, move to the new test case to the garage. I didn't mention that, just this is the main function I work on for this sprint.
So what is the connection between OBS and ONOS?
The connection.
No, connection, physical connection or the VM to VM connection? What type of connection you have? 1 gig
physical
or 10
to physical
gig?
to physical.
1 gig,
physical.
1 gig or 10 gig?
Scale or 1 gig?
1
yeah,
gig?
Yeah.
Is that enough for 600 routes to?
That's not because I inserted with the speed control, so that's not a big problem. Yes.
Okay. Clearly, there's more work to be done here. Yeah. Okay. There's also some work done by external contributors on adaptive flow subsystem, which collects flow statistics using certain heuristics to be able to adjust the frequency for data collection. If there's somebody online that would like to speak more to this. Given the time difference, it may not be likely. But there's the review is currently still in progress. It went through a couple of different rounds, but I think it's near going near the point where it can be pushed through. Because what this does, it replaces the existing flow manager with this revised one. Because the existing flow manager does things on a very rigid and sort of constant rate, which also I think is something that was hitting the SDNIT performance. Security mode ONOS, clearly there was work done mostly in characterizing the performance, and so there were some investigations about possible approaches to avoid the performance penalty when checking the API level security. And we had discussions with Changun and with Phil about those approaches, and that will be work that will probably be extending for the next couple of months. Okay, I think, is there anybody from Comcast online to talk about the multicast? No? Sorry, DirecTV, sorry, DirecTV, yes. Yeah. Okay, so if that's that, then I think what we can do is we can move over to the demos. I was thinking I could start, and we can probably start in different order. So first of all, I'm just going to demonstrate a simple setup of the scenario test coordinator, which is intended to do the verification here. Let me peel off a new window here. to make it bigger so people can see. So the idea here is for the scenario test coordinator. It's basically it's intended for both developers as well as for the automated build verification. It's a small command line tool which will have a user interface eventually. The user interface is in work in progress and it's only a spare time activity right now. But the idea here is that you can define scenarios. One of the scenarios that I'm going to demonstrate is a simple setup scenario that will take my existing cell, which is a cell TOM-X, which comprises of these of 3 controllers and 1 mininet machine. And using that environment, I can now run the scenario test coordinator, the simple setup scenario. And what that will do, it will simply take the existing bits that are packaged. It'll uninstall, completely scrub, clean the cell. Make sure that it's everything's been shut down and killed off. It'll push the bits to the cell, and then it'll do install and then configuration and wait for everything to start up. Now the test coordinator, the scenario coordinator, it runs as many things in parallel as it can. So there's essentially a process flow graph that it follows and executes things in order of dependency. And this nicely compresses things into a fairly compact time period. Not sure what's happening here. Demo syndrome here. Let me just run the overall scenario here.
What other types of scenario coordinators we have other than setup?
Well, there's so so currently what we have is just some basic operation. Be able to set things up, scrub the logs, make sure that there's nothing bad in the logs. Be able to do ping all, just basic reactive forwarding test, intent test, and stuff like that. But it's very rudimentary. It's not intended to replace the system test at all. It's something for developers to use to be able to get their environment up and running and to be able to prove that this thing is working when they get the bits. And it's also uses mininet topology, and it's portable. It uses the cell concept that we have established. But of course, I think the demo gods have reared their heads, and I think there's some issue with this stuff. So that's what I get for checking out the latest right before the demo. But you get the gist. It runs in parallel and it sets things up and basically shows you what has passed, what hasn't. And if you need to have access to the logs, you can easily review the logs. For example, the reviewing the logs, I can see what has transpired during the installation of this, and each of the logs is nicely STL. So it can shows you, if there was more logs, it would show you what logs have basically logs collected, and so you can see exactly what each command did and stuff like that. The idea here is that for Gerrit, we want our builds to run fast. And so but we don't mind spending extra few minutes to get the confidence that the change that's going in is not going to affect the overall build. And so the scenario that we're looking and deploying would be something that would take on the order of like 2 to 3 minutes, and that's it. It's not intended to be a huge comprehensive test, but just simply saying this thing works, good enough, and we can move on. It would catch DOA failures that we've had before, would escape us, and it would cause the code to be merged, and then it would affect number of developers that are now stuck because the thing is not working. So that's the whole. It's basically a sanity, yeah. scenario, sanity test, whatever you want to call it. Yeah.
Would it be part of the 90 Jenkins too?
Well, actually, would be. I mean, we could make a more extensive scenario as part of nightly Jenkins build. But I think again, the idea here is that this is not intended to replace the existing test on or anything like that. The idea is just to give us a quick verification. Now, because this is a verification that Gerrit's going to run, we also it's fair that the developers have a chance to run it too, to make sure that when they run it, they can run the sanity test on their own before they check stuff in.
And that's what I'm saying. Why not the environment in the Amazon where it's hosting the Gerrit, unless we can tie it back to Proxmox, or we can build it on Amazon for the
right. So this is intended to be able to run either on Proxmox by developers or potentially on Amazon, which is where probably most likely Gerrit would be running it at. But we haven't. The reason we haven't put it into Gerrit yet is because we need to work out the tunneling onto the access to the Amazon. How do we set that up? Plus, also we allow Gerrit builds to happen concurrently, and so we need to have a way, sort of a leasing mechanism to make sure that we have a test execution environment that's either allocated on demand without costing too much money, and that can also run in parallel in different environments. Because the last thing we want to do is choke point the Gerrit build to run only in one environment. That would slow us down. So it's almost ready to go in. Apparently, there's still some sort of a glitch, but you sort of get the picture. Also, as part of this, I believe if I were to, unfortunately, I think I have some issues. So I'm not going to be able to demonstrate the cluster IP application. I'm just gonna, rather than wasting everybody's time, I'm just gonna skip this. So besides, it was a small thing anyway.
You need to define this cluster IP in the same set file, or is it separate configurations?
Oh, the cluster IP, that's not something that's being automatically tested. That's something that, if we do test it, then it'll probably have to be defined as part of the cell file. Yeah. But right now, this was just a little extra project written because there was a need discussed for having some sort of a team-wide IP address. Yes, in most heavy-duty production environments, you would probably have something like HA proxy. You would have team, NIC bonding and other types of setup. So that type of an application would not be needed. But if all you need is just a simple aliasing for your team, and then you can just simply start the application, configure it, and you're good to go. Unfortunately, because the scenario testing has broken my cell, I can't demonstrate it. So. We can demo it some other time. It's not a big deal. I think, Simon, do you think you will be ready to do the demo?
Hi, yeah, sure. If you could provide me with the ability to share my desktop.
Okay, I'm not sure. So stop sharing. How do I make you presenter? Make presenter, there we go. You need to switch to a desktop version of the GoToMeeting to be a presenter.
Oh, crap. Okay, sorry. I don't remember where to do that. Hang on.
So maybe in the meantime, what we can try to do is see if the Huawei team wants to give a good demonstration.
Sure, we'll do that, and I'll figure this out.
Yeah.
Yes, I'll give you
sure. James.
Yeah, hello. This is Fanindra. I would like to demo for the PCEP SBI tunnel provider.
Okay. Okay.
Yeah, I can. Can I share my screen?
Yeah, I'm trying to figure out. I need to give you a presentation rights.
Okay. Okay. Okay.
It was a little further down. No, that's yeah. I'm trying to click on it. Okay. You also. It says that you need to switch to the desktop version of GoToMeeting in order to be a presenter.
Yeah, we are using desktop.
I think you might have the wrong one. See if you see one that doesn't say web. Wait, there it was. Oh, you just went right, I think. There you go. Oh no, it says web. So,
I don't know. I don't know what to tell you. Right now, you show up as using web client. So
have you installed the GoToMeeting? Hello? Okay, let me go first.
yeah. So I'm gonna let James go first. Okay.
Hello, I'm installing the GoToMeeting. Please give me a moment.
Yes. Here. Well, let me 1 second. I'm gonna try to send you the invite here.
Okay.
Make presenter. And okay. I don't know what that did, but okay.
What are these tools?
Okay. So as soon as you share, I'll be able to see it here. Yes.
So actually, I'm going to run the demo of the ONOS framework for the OpenNet. So actually, I'm not going to enlarge this screen because I'm going to show other screen at the same time.
Okay.
Because this demo will actually the Huawei team in China to run this demo in their environment take like more than 20 minutes. But my machine is quite slow, so if I run the demo from beginning to the end, probably will take more than 30 minutes. So I just use this slide and plus some like you see the environment to show everything how this demo is going. Okay, the first thing is okay. So the first we're going to like start the okay. I'm going to introduce the environment for this demo. So far, I have I have clusters of 5 nodes, 4 nodes for the OpenStack, 2 nodes for the compute, 1 node for the controller, and 1 node for the networking, and 1 node for the ONOS. So the total 5 nodes. So I can show everyone here. So okay, don't look at the first one. So this is the compute node 1, 2. This a controller. This is networking, and this is the ONOS. The total 5 nodes here. So running on my laptop.
You can run 5 VMs on your laptop.
Yeah, so it's quite.
Each one's okay.
Yes, that's okay. It's quite slow. It's quite slow. So, a reason. So, the first thing is actually here is the ONOS the node here. I start the ONOS, and the first I'm going to install this the 5 modules developed by the Huawei. The first one is the OVSDB database. The second one is VTN resource. Third one is VTN. The last one is the VTN web GUI. So this the 4 total 4 modules. I run this first. Second, so
Question, why can't we just use one command to install or enable all those?
Yeah, I think that
They need to be separated?
I think probably that's a good suggestion. So we can let it for next sprint. So let the Huawei team to do the further investigation. So I think that's a good suggestion. So.
And I assume it would also be using the application subsystem rather than raw features.
Right.
So that it happens on across all.
Right. So actually, just for the module is based on entire existing the ONOS the features. We just added this the four. Okay.
So the OVS DB feature will install all the three components that you have in your slide, right? Controller, provider.
Right. So everything there. So everything there. So this part is running on the ONOS part. Second, so we're going to let's look at this. Okay, the first one starts the ONOS, install the VTN. So I just you see show everything there, the feature install this. The second part is to create a provider network. I'm going to show everyone how to do that. So for this, okay. So the three nodes here. This first one is the compute node 1. The second is compute node 2, and the third one is networking node. It's running the neutron, right? So actually, we use this command. Okay, all the three nodes will run this command to set up the provider networks. Set up manager. Actually, you just added ONOS. The ONOS is SD controller, right? So we put this SD controller there to set a manager to let all the three nodes know the ONOS controller. So
The 116 is the ONOS?
Yes.
212.
Yeah.
And this is port 6640.
Yeah. Let me show you here.
These are the result port.
Doesn't listen on 6640.
No. You see that? The first one is 116, right? So all this is the ONOS the ONOS node, right? So here, so we just use this command to set up the provider networks.
How are you doing port forwarding?
Question?
6640 is not a port that ONOS listens on, right?
It's the manager, that's the OVS DB, right?
It's the OVS DB manager.
Right.
It's not the controller.
So this command starts the OVS DB server on the compute nodes? Or what does that do, set manager?
It just configures the OVS DB.
And actually, after, because I already configured that, I'm not going to run that. After you configure that, so if we show this the VXLAN here, so you can see. Where is my mouse? Okay. And you can see we already set up the VXLAN. So in the compute node, this controller, we don't need controllers. So you see this the same thing, right? So the same thing. So all the three nodes got those information. So if we go to ONOS GUI, so you can see. Yeah, that's we got. This three is the OVS. You see, I click this. See that? Is this on the left side? This the open vSwitch, the three, right? Because I run this command, so this is VXLAN there. So
I think press H, it will show the host. I wanted to see the host.
I think there's yeah, because right now, so 1, 2, 3. I already created 1, 2, 3, 4. I think it's 4. Let me double check. Let's see, 4 instances there. 6.
How many virtual tenant network are you trying to create? Just one?
Virtual network, actually it's total 2. I'm going to show later. So, sure. Okay, let's see this. Okay, from here you see here is I have 4 instances created there. So
but there are 6 appearing in the ONOS GUI, right?
Yes, I think there's another 2. They told me is the DHCP server in some place. Oh, also. The China team also found the bug on the GUI side. Actually, I also noticed there's not like a very accurate for that. So they saying so they actually they found the bug for that. So.
And what are those grayed out boxes in the GUI?
I think this one is like the node. You see here is you see the IP address there.
Oh, this is the OVSDB endpoint.
Yeah, so that's OVSDB devices. Yeah, those are the compute nodes.
Yeah, we're gonna find a way to not show both.
No, they're show the devices at this point in time, right? The controller devices. So there'll be more enhancements.
So okay, this I create a provider network, and the next step I'm going to talk about how to create the VTN network. So into here. So first, so what? Give me a second. The URL is not correct. This is right. It's just slow, so just running, so it's kind of slow. Okay. The first, so I created networks. Okay. First, I create the demo networks here. So the network is like this. It's 192.168.10, and on this I create 3 instances running on this networks. Because here is I created 3-1. All the subnet is 1. Is 2, 4, 5 here, right? So, and those nodes should be can be talk to each other, right? So actually we can use the pin to try that. Okay, this another slide I already talked about it. Okay, so actually we can go through this scenario. So I created 3-1 and it just slow.
So those 3 instances are running on 3 different compute nodes?
Right. So you see this one, you see this. Wait a second. So I can log out. I go to the admin, so you can see which instance run which node. You see one. Okay, you see demo in 1, in 2, in 3, right?
1 and 3 are on the compute node.
Yeah, in and this 1 and 3 running on the compute 1, 2 run the compute 2. So that's the thing. So
ONOS doesn't see the VTN at all. ONOS only see the provider network. But ONOS doesn't have the concept of VTN. Right. All right.
No, this VTN goes through ONOS, right?
Right, but on ONOS, only aware of the provider network, as far as I can see. Right? It doesn't have knowledge of the VTN itself, or does it? I don't know.
Well, it's so the ONOS existing ONOS providers, yes, correct. But I think there's the VTN application on there does know about the virtual networks that were created through this.
On ONOS GUI, it doesn't reflect that, or it doesn't see.
On a GUI right now we don't have, we don't visualize it. But ONOS, the application does have a notion of which switches belong, which ports belong to which network.
So it does have
yes, that's the VTN application that manages that.
This one, so I got a console of the this one. Let me see the IP address. Yeah, it's the instance one is 1.2, right? So here is the first one is 1.2, right? And then yeah, if everything is okay, so instance 1 can pin instance 2 and pin instance 3 because all this on the same the networks, right? So, 4, 5. 4, 5. See, it's working, right? So let me pin 5. Okay, it's working.
So did you say you created 3 hosts and all 3 you put into the same virtual network?
Yeah. Also, I create another one. I'll show you later.
On a different computer,
yeah,
go through the slide.
Yeah.
Basically, that's what I'm doing.
Yeah. I think this slide can make things. First, I created 2 instances on the different the nodes. And the second one is I create a third one. So on the host one, the two instance on the host one, right? This one is the host 2. And then because those guys in the same subnet, so they can ping each other, right?
Okay.
And the last one is different, right? So different is here is we created admin different the tenant, tenant. This guy should not pin all of them, right? So that should not work, right? So let me try this one.
So the network node in your setup will be used only when you send the external traffic.
So
you have a network node also in your topology, right?
Right now, actually, we just use the pin, right? So
when is that network node being used at all in this demo?
Control the neutron, right? That's
neutron, yeah. So I can show you how to create the instance. So lost a little bit. Okay. This one. Here, the subnet is 10, right? 10.2. And right now, I'm on the instance 1. I'm here. I try to pin admin instance 1. Actually, this guy is based on the network, based on this one. You see, there's another admin network, the second one I created. The previous we created that demo network is start with 1.0. This one is 10.0. Okay, so and
was 10.2, right?
Yeah, 10.2. Yeah. So if I right?
So where is this happening? Where are these packets getting dropped? Where is the isolation happening? Do you know?
In fact, ping is not a valid path. So, I mean, unfortunately, in a different subnet, you can't ping the whole subnet. You probably want to sniff out on the other subnet to see if you see the packets. That's more validated test. But by virtue of subnetting, you don't see it at all. You only
there is no router.
There is no router. If there was a router somewhere, then that's not. Then ping is a valid connectivity isolation test.
But I think it's from what I understand, it's the VXLAN, right? That's the isolation.
But the VXLAN is the isolation.
The fact that you're putting a different virtual network identifier.
There is only one VXLAN, only one pipe. One pipe.
There's only one pipe, right?
Yeah, there's only one pipe.
But if you go back to the definitions of the ports on that pipe.
This one?
No, the
picture.
The OBS DB output, the OBS VS kettle output. Yes.
Okay.
So you see the okay. So the VXLAN links are between local and remote IPs. Okay, those are like infrastructure IPs. But the VXLAN identifier, network identifier, says flow, which means that while creating the tunnel, you're not saying what the virtual network is going to be. Okay. When you're actually forwarding traffic, right? That's when the virtual network identifier gets put in. Okay. And
right now the packet is not going out anywhere. It's a ping packet. If it goes out there and if it gets dropped on the other side, then we know that it is.
Yeah, that's why I'm asking. Actually, I don't know where exactly it gets dropped.
It will drop here itself because there is no route. Machine will drop it anyway.
Wait a second, I can show the.
Without a router,
Yeah.
you mean, right?
Yeah. Unless you need a route.
Actually, ARP won't have.
Packet doesn't even go out of the interface.
Yeah, that's about it. Something. So that.
Right. So this
different way to validating is not pain.
In fact, I mean, you should be, because you're putting this one in a different virtual network than this one.
Then you should
be able to the same IP. You should be able to give. This one should have. You can give it any one of these three IPs. Hold on. If you give it the same three IPs, any one of these three IPs, then you do the ping test. That's valid, right?
But I don't think OpenStack allow you to set up something that way.
Okay, that I don't know.
The virtual tenant network cannot be in this. At least on the old Neutron, I'm not sure the new.
No, it does allow.
But it should be basic, right? I mean, address space isolation is a basic requirement of virtual
Absolutely.
networking.
I mean, that's
right?
the right test is giving the same IP range.
Yeah,
and you
I saw
think
that scenario
that's a valid test.
before.
Right now they don't have VLANs also.
They should
Once they
set
have
up the same
VLANs, I think they can use the same
IP address
VLANs in the separate pools.
on the different.
But at least on the old Neutron, they don't allow you to set up something in the overlap. Anyway.
Yeah, but actually, I think probably those IP address get by the DHCP. So right now you see actually when I create the instance here, whatever, just create an instance there. So you see, if I create an instance here. If I go to the networking, I think somewhere so.
It's okay, then you define it.
Okay.
We can probably do that later because we're running a little bit short on time.
Sure.
So we can is that right? We can demo that later.
Yeah. Okay. I think yeah, more that's all. Yeah, that's all. Okay.
Cool. All right. So is that it?
Yeah.
Okay.
That's
excellent.
it.
Thank you.
Thank you.
So let me give one more chance to India, team in India here. Maybe guys.
Yeah. Hello. Can you give me the permission to share the screen?
Yes. Who is this exactly?
This is Fanindra.
Okay. It says that you're web. That you're using web client. If I make you a presenter, it says that that you need to install the desktop version of the GoToMeeting.
Okay.
You
mean to say the Chrome extension or something? Is it different?
I think you need to download the application, GoToMeeting application, and then join the meeting that's in the invite. Because if you're using a web client, apparently it doesn't allow you to be a presenter.
Okay.
So you want to try doing that while maybe Simon gives presentation on a demo of the UI? Okay.
Yeah, sure. Okay.
Hey Simon, I'm gonna give you the presenter rights.
Okay. My screen.
All right, we see you.
Oh, you do?
Yep.
Are you seeing the ONOS GUI and the three?
Yes, that's what I meant. We see your.
Okay, cool. Yeah. Well, I've got two running. That's all. I wanted to be sure you're seeing the right one.
Yes.
Okay.
A couple of demo. Yeah, in the list. Yeah.
Okay. So last time we looked at this, I had already started work on the overlay concept, and we had a slightly different toolbar down here where, under normal circumstances, we don't have an overlay. And so, it's basic functionality for selecting nodes and links and hosts and so on. If you notice in the detail panel here of the selected node, there are 4 navigation buttons to the different views. So, for example, we could go look at the ports for that specific host. So going back to topology and selecting that node again, for example, an overlay is basically a functional module of software that can be installed into the topology view to add new behaviors. And so the existing traffic behaviors that we had before have now been kind of yanked out and reformed as an overlay. And so it has to be activated by clicking on this button here. And you'll see a couple of things. One is we now get these buttons down on the bottom row, which are part of the traffic overlays functionality. And also the overlay can affect both the summary panel and the details panel. You probably saw these 2 new buttons appearing. And so this is traffic functionality that is applicable within the context of the selected item, in this case the device. So let me just show you pretty quickly. Here's monitoring using port stats. And if I were to use Mininet to, say, H25 pings with very large packets, so they actually show up in this port stats H44, and get that going. Because we're monitoring with port stats, you should see the GUI react, and you can see that traffic on there. Okay. So that's one mode. We've also got a cancel button here that we knew from before to cancel that. Another thing that we can do at the moment, you'll see that we have 0 intents on the system. I'm going to push some random intents, say 20, and we get 20 installed, and you'll see now that the intents have gone up and the flows have gone up. And so if I were to, say, select a node and then say show flows, you'll see that the number of flows egressing from that device will show up on the thing. So this is all old behavior that we had before. It's been tightened up a little bit. So, for example, you can multi-select items, and it's kind of additive in this particular mode. But the next thing that I wanted to show you was related intent. So related intent is basically you can select a node and you can say, show me all the intents that this node is a part of. And so what you get back is basically a highlighting of all of the links of all of the paths of the intents for that specific node. These previous and next buttons or arrow keys will now take you through and cycle through each of those paths in the group. And then we have the monitored traffic of a specific intent. So by clicking this or pressing the W key, we're now in a monitoring mode where any traffic that's on the line will also be shown in labels on the links. Now, a couple of subtle things here. One is that all of the nodes and links not in this path have been partially suppressed visually. And also we've got the marching ants that was so long requested after not having them. From this mode, we can continue to select additional paths from the current selection and then monitor the traffic on there. Or we can just cancel it like that. So what I'm showing you is not a lot new visually, but under the hood, it's been completely reworked. And part of this is to allow, as I said before, what we've done is we've decoupled the semantics of what's being displayed to the actual display, the presentation, to provide a toolkit for an external party to use. So over here, I have a development environment which is totally a new development environment. It's taken off one of the GUI archetypes, and I've pre-built my little application. for the Meowster company, and we have an OR file, and we're going to install it and activate it on localhost. If I were to very quickly do apps summary for active applications, you'll see that we have 5 listed here, all from ONOS project. Once I load in my Meowster app and we do the same thing, you'll see that we've got a new one, Meowster overlay, here, 1.0 snapshot. Now, by refreshing the UI, what's going to happen is we'll basically reload the resources for the UI, and in part of that application installation, it's integrating its implementation of a topology overlay. And if you look in this toolbar now, you'll see that we have an additional button. This has been provided by the Meowster overlay, and by activating this, we've basically allowed the external application code to modify what the summary panel looks like, and also it can modify what the detail panel looks like. It can add its own buttons for context-specific functionality, and the new thing that I've been working on the last couple of weeks is basically interacting with the server-side business logic to be able to produce new topology functionality. For example, I can click on this button here, which says Start Mouse Mode, and in mouse mode, what it allows me to do is I can hover over a node, and what actually happens is the application code. Oh yay! The application code goes to the server with a note of which device was hovered over, and then my application code on the server side queries the device service to get the device, and then it finds its egress links, and then it figures out which ones those are, and then sends a message back to the topology view to say, hey, highlight these links for me, and also set the labels. So you can see the labels are being set as well. Let's remove the port highlighting, that's confusing. So that's one mode, and then an alternate mode that I did just for demo purposes is what I've called link mode. And what this does is it starts up a little timer on the server, all in application code, that gets the active links from the link service, and then it steps through them and then sends a visualization back to the UI. So these are really just simple examples, simple interactions of the model of devices, links, etc.
Uh-oh, you're breaking up, Simon. Are you still there?
So
we see your screen, but your audio is breaking up.
Yeah, sorry about that. I'm going to keep talking, and hopefully some of this comes across.
Yes, it's coming across fine now.
Okay, so this is a simple demonstration of how to use the topology overlay toolkit to be able to interact with the topology view from an external application and provide new functionality or new behavior based on gestures that the user might use. So that's basically it. And I can relinquish control.
Great, thank you. I think that's actually. I think you were the last presenter. Let's try to see if we can get the India team on.
Crazy. It's 4 in the morning.
Yeah, unfortunately, I don't. It says that he's offline.
Yeah, I think the connection is tricky.
Is it our connection or?
No, his connection. He's showing 2 entries. One is offline, one is web. GoToMeeting is confused.
Poor guys. Do the whole thing and then
Unfortunately,
Thomas, they're trying to install the GoToMeeting.
Yes.
Yeah, they should install plugin. It should have prompted them as soon as they started, right? Usually it installs before.
Oh, he's running a
Goodness.
But the GoToMeeting is not supported for Ubuntu, he said. So
He's not.
He's checking
Yeah,
other option.
yeah.
So maybe
I think unfortunately we probably won't be able to do the demo then this time around. I think would be maybe.
Yeah. You can put a video.
Maybe that might be a good idea. Just do a screen recording and just send it out.
Yeah. Okay.
Unfortunately, that's. Okay. I think with that we can call the sprint done. I'm going to close the sprint at the end of the day, and there won't be a new sprint at the end of the release. There will be just, as I mentioned earlier, there will be just some wrap-up activities. Most likely, we're expecting to cover release candidate next week, early next week, either Monday or Tuesday, and run some tests on it, and hopefully, no more than one more, and then we'll be able to release. Okay? Thanks, everybody. Have a good weekend. Bye-bye.